Hi, and welcome to this video about Chapter 5. As we move into Chapter 5 from Chapter 4, we start to look at doing estimation with confidence intervals, and we do this with in Chapter 5 with a single sample. And so a few of the things that I wanted to point out to help you as a supplement to the Chapter 5 material is just to show you a little bit about how the notes for Chapter 5 are set up and to show you the Statcrunch steps, and then to maybe even go into Statcrunch and show you the options for Chapter 5. So in Chapter 5, we will be working with 4 different types of tests. We will be doing a confidence interval for a population mean for a normal z-statistic or a z-test. And if you follow through the Chapter 5 PowerPoint, you will see that there are examples. So here's your problem. Here is the problem worked out by hand, and then here's the Statcrunch steps for how you would go into Statcrunch, stat, z-stat, one sample with summary, enter the information from the question, choose compute, and you get one of these printouts or windows that basically gives you the confidence interval for the lower limit and the upper limit. And so here again, another question. And this is a SAS printout. It's basically just a different statistical package than Statcrunch. There are many of those out there, SAS, SPSS, Minitab, Statcrunch, and so they all yield the same kind of information in terms of giving us the information we need for the problems that we are working. And so you can go through and you can see that it's all outlined here. Now when we move into 5.3, we move into confidence interval for a population mean with a t-statistic. The big difference between a z-statistic and a t-statistic is usually your sample size. Z-statistics are normally used when you have a sample size 30 or bigger. T-statistic is used for a small sample size less than 30. And again, you're getting the idea of the different distributions. If you see the blue line here, that's your normal distribution. Then you get a t-distribution and with a degree of freedom of 4, and then a t-distribution with degrees of freedom of 20. What happens with your degrees of freedom is that for a t-distribution, your degrees of freedom is n minus 1. It's your sample size minus 1. And so you can see explanation on this slide. Your t-statistic is more variable depending on your sample size. So a sample size that's larger, has a larger degree of freedom, is going to be more variable than a smaller sample size. So your sample size, your variability depends on your sample size. So just with the z-statistic or the z-score, you have a t-distribution where you look up your t-values as well. And then again, you have problems. Notice this is a small sample size. It has 6 patients, blood pressure for 6 patients. They do show computing by hand, computing your confidence interval, your t-statistic, and then if you go a little bit farther in, I have added in Statcrunch steps for you on how you would go into Statcrunch, t-stat, one sample with data, enter the information in, and then it gives you your output. It gives you your lower limit and your upper limit for confidence interval, which you can see matches what they have here, 1.287 and 3.280, rounded off. Theirs is rounded off, but it matches what they have come up with out of SPSS. So we've covered z-test and t-test. And again, you can see several examples, several other bits of information. Then we move on to large sample confidence intervals for a population proportion. So again, a proportion is the third type of test that we will be doing. And you'll start to notice with a proportion, and one of the ways you pick out the proportion problem, you'll start to see this little symbol of the p-hat. It's called, it's just a p with a little notation on top. And so that basically starts to tell us we are switching over to a proportion problem. Your proportion problems will also start to talk about a P and a Q, and it will basically tell you that there's so many out of your sample size, a percentage or a proportion out of your sample size that has a certain characteristic. So again, you can see this problem worked out by hand with the test statistic, and then you can see Statcrunch steps again with the printout matching the answer that they have, and this is a mini tab printout for what the textbook provided, but here's our Statcrunch stat proportion stats one sample with summary, and this gives us our lower limit and our upper limit for this question as well. So again, you can see all of the formulas, you can see everything that you might need. Section 5.5 is on determining the sample size, and you get a couple of different formulas on being able to estimate a sample size depending on the information that you have. So you'll have a couple of questions that ask you to use the sample size formula. And then your last type of test that we will do, your confidence interval, is for a population variance. So when we get into population variance, we get into something called a chi-square. You'll start to see this chi-square notation. It's kind of a funky curved X with a power of 2. And again, you'll see that this one is built on sample size and degrees of freedom. Again, here is our confidence interval formula. Hopefully you'll agree it is a lot better to just look at Statcrunch and let Statcrunch do that for you, but you can if you want to do that by hand. You do have your chi-square table with your critical values, just like we had with your z-test, your t-test, and your population proportion. And then that takes us to the end, and I want to go out to Statcrunch now and show you the options for confidence intervals within Statcrunch. So I'm going to go over to main menu and Statcrunch, and then Statcrunch website, and go ahead and open up a blank Statcrunch window. And so underneath stat, you'll notice we have z-stat, t-stat, proportion stat, and variance stat. Those are the 4 options we will use for Chapter 5. It's also the 4 options we will use when we move into Chapter 6. So if we just choose z-statistic or t-statistic, proportion, or variance, you'll notice that they all say 1 sample or 2 sample. We are working with 1 sample only in this chapter. So whether you're doing z-stats, t-stats, proportion stats, or variance stats, you will always choose 1 sample in this chapter. We're not at a point yet where we're comparing 2 samples. And then you have another choice once you choose 1 sample for each of these. You'll notice the other choice then that we're going to be concerned with is with data or with summary. So if they give you the data, the data set, you will want to open that data set in Statcrunch, and then you would choose with data, and you would select your data column, and then you would change this option to confidence interval. So keep in mind, we are doing confidence intervals for Chapter 5. For Chapter 6, we are going to be using the hypothesis test option. So confidence interval, the level of confidence will be in your question that should be given. Most of them is 90, 95%. There's some common levels of confidence. You would choose that, and then you would choose compute. So again, z-stat, t-stat, proportion, or variance, 1 sample with data or with summary. With summary means they have given you the information in the question. In this case, because it's a variance option, they would have given you the variance, the sample size, and then you would choose confidence interval and put in the level. So what I would like to do now is go in and at the risk of making this video too long, I want to go in and I want to grab a question from Chapter 5, and I want to show you what it might look like to go in and do one of these with Statcrunch. So, see here if I could make my window a little bit bigger, my recording window. So here we have periodically a town water department tests the drinking water of homeowners for contaminants such as lead. The lead levels in water specimens collected for a sample of 10 residents of the town are shown to the right. Estimate the true mean lead level in water specimens from the town for a 95% confidence interval and interpret the result. So what we're going to do for this question is just to click this little thing that would allow us to open our data in Statcrunch. And since this is a small sample, 10, less than 30, we have our data that we have copied from our table of our lead levels for the 10 samples. We're going to go to Stat, T-Stat, one sample with data. We choose our column. We choose confidence interval because that's what we are computing. 95% confidence level, which is already in there for us, and we compute. And it does do a couple of other things for us. It gives us our sample mean. It gives us a standard error. It gives us our degrees of freedom, which notice is 1 less than our sample size because degrees of freedom on a t-test is n-1 or 10-1 in this case, which is 9. But it does give us our lower limit 0.033 and then our upper limit 5.729, which we would round that to 5.730, and that is our confidence interval. Then what we can say is that we are, the water department can be 95% confident that the mean lead level in drinking water for all residents in the town is within this level. So it gives us the ability to say, to add a little bit of a confidence to what we're saying in terms of statistics. So I hope this video has been very helpful. If you have other questions or comments, please let me know. And I look forward to working with you this week on Chapter 5. Thank you.